Hi, this is some video help for lesson number 46, Tuesday of this week, and we're graphing inequalities, which means we're going to get a graph that is not just a line necessarily, but also a shaded area. When it's in the slope-intercept form, when it says y greater than something times x plus or minus something, we start by drawing the graph of the line that we would have if this was an equal sign. That means I go to that y-intercept of -5, and then I see the slope is a positive 2, which tells me go up 2 over 1, up 2 over 1, over and over. And when it says strictly greater than rather than greater than or equal to, that means the points that would be on the line are not solutions. It's kind of a fine detail, but it's an important one. That means do not make a solid line, make a dotted line or a dashed line when it says strictly greater than or strictly less than. Now, we're either going to shade this part of the graph or this part of the graph. When it's in the slope-intercept form, it's very easy decision. If it says y greater than, you shade above. If it would say y less than, we would shade below. This says y greater than, so we shade over here. And you don't have to spend a half hour making a mess. Just make some lines like this. You'll see the way they do it in the textbook, very similar to this. Okay, so that's one of the examples from the number 46 paper. Here's y is less than 4x minus 7. So we start at the y-intercept of -7. The slope is a positive 4, meaning we go up 4 over 1, up 4 over 1 a few times. It says strictly less than, so that gives us a dotted line again. And since it says y less than 4x minus 7, we shade below this line. It kind of looks like to the right, but look at it this way. This would be above, this is below. Okay? Here's another. This time it says less than or equal to. So we start with the same idea. It's in the slope-intercept form. The y-intercept is -4. 0, 1, 2, 3, 4, right there. Slope is positive 3, so I go up 3 over 1, up 3 over 1. And since it says can be equal to, we're going to make it a solid line. Okay, so there's, see, the difference here is any point on this line will be a solution because the y value will equal exactly 3 times the x value, take away 4. On the other graphs we drew, the points, the billions and billions of points that are in the shaded area will satisfy this condition. The y will be less than 4 times the x minus 7. The points right on that dotted line won't work, because the y will exactly equal 4x minus 7. We don't want those, that's why we made that dotted. Okay, so that's the fine detail difference. So where do we do the shading? It says y less than, so we shade below. We shade over here. That's it. If you're artistic, you can get colored pencil or markers or whatever. Use a paintbrush. Make it beautiful. Anyhow, there's the finished graph for that one. Here's sort of a special case. It's just a y, no x. Remember, y equals -3 would be the horizontal line where the y value was always -3. So there's 0, 1, 2, 3, and this is going to be a solid line. It's going to be kind of hard to see, I guess. But there's the line with all the points where y is exactly equal to -3. We also want all the points where the y value is greater than -3. Well, that would be above. So you just shade above that line. And that takes care of that. Now, all these so far have been in the slope-intercept form, or just that horizontal line? What if they're in this form? A little more work, but not such a big deal. We start by, just a minute please. We pretend that's an equal sign for a moment. Plug in 0 for x, solve for y, you get -2 for the y-intercept. Plug in 0 for y, solve for x, you get +5 for the x-intercept. What kind of line are we going to use here? Again, a dotted line, since it says strictly greater than. And now we have to decide whether to shade above or below, and it has nothing to do really with the direction of the sign. What we have to do is plug in a point and see if the point works. And if the point works, then we shade the side with the point. And what that comes down to is this. Plug in any point you want from here or from here. What's the easiest point to plug in? 0, 0. If we plug in 0, 0, it's going to say 0 minus 0 would be 0. It's saying that 0 is greater than 10, and that is false. That tells us this is not the correct side for the shading. We want to shade the other side. And that takes care of that. Okay, hope that helps. The family is yelling at me to come to dinner, so I'm going to cut it off right there. Take care. Bye-bye.